Here we are back again with a little bit of algebra. We are in chapter 1, section 6, solving absolute value equations. Absolute value. You remember those absolute value bars? Here are a few properties of absolute value. First off, an absolute value of a number is always going to be greater than or equal to 0. Next, the absolute value of a negative number is the same as the absolute value of a positive number. So the absolute value of negative 5 is the same as the absolute value of positive 5. Next, the absolute value of a product is the same as the absolute value is the same as the product of each one of the absolute values of the terms. So 5 times negative 4, absolute value of that is 20. Absolute value of 5 is 5 times absolute value of negative 4, which is positive 4, comes out to be 20. And then the same goes for division. Just remember, in division you cannot divide by 0. So that works unless b is 0, of course, because you cannot divide by 0. Okay. Now, when you're solving absolute value equations, remember that the absolute value of x is, if it's 5, then x could be, we have two different situations. X could be negative 5. So x could be positive 5, but x could also be negative 5. Right? Because both positive 5 and negative 5 have an absolute value of 5. So when you are solving, you have to consider both these cases. So if x has a coefficient plus something else, and that equals c, well, this inside here could be positive c, or it could be negative c. And this only works, obviously, if c is greater than or equal to 0, because the absolute value can never be negative. All right, let's solve a couple of these and graph the solutions if possible. Okay, so we're going to have to solve two cases. X minus 4 is positive 6, and the other case is x minus 4 is negative 6. We're going to add 4, because the inverse of a negative is a positive, the opposite. So we add 4, All right. Over here, this cancels out. X equals 10. And on this side, this cancels out. X equals negative 2. Okay, here we have two solutions. We're going to graph these on a number line. When you're graphing them, I've got x equals negative 2. I'll put my dot at negative 2. And then over here, I'll put my dot at positive 10. Now, if you look at this number line, notice the number in the middle here, 4. Where does that appear in my original equation? That number in the middle is this number here. Now the distance from negative 2 to 4, 2, 4, 6, that distance is 6. From 4 to 10, 2, 4, 6 is also 6. This distance appears right here. Remember, absolute value describes a distance from a point. Okay, example B. Can the absolute value of anything ever be a negative number? No. So this is not possible. You cannot solve that. All right. We want to solve an absolute value equation. We first want to get the absolute value by itself. If there's anything outside of that, get rid of this. So we're going to add 10 to each side. This cancels out. Now we get the absolute value of 3x plus 9 is 6. Okay, initially it said negative 4. That's not possible, but once we added the 10, now we have 6. So the absolute value can be positive. So now we have to solve two cases. Either we have 3x plus 9 is positive 6, or we have 3x plus 9 equals negative 6. There is another way that you could have solved this. I'll show you in just a second. Now we solve it the traditional way. We're solving for 3x, so subtract 9 from each side. Subtract 9, subtract 9. We get 3x is equal to negative 3, divide by 3, and x is equal to negative 1. And then over here we have 3x is equal to negative 15, divide by 3, and x is equal to negative 5. In the first step here, or in this step here, we could have also divided this entire expression by 3 and factored out a 3 out of this right here. So that's another way to solve it. In a cheerleading competition, the minimum length of a routine is 4 minutes. The maximum length of a routine is 5 minutes. Okay, so we have a minimum and a maximum there. And we need to write an absolute value equation for that. So the minimum is 4 minutes. The maximum length is 5 minutes. There's a couple different ways you can approach this. Here's one way. We make a number line. We say, where's the minimum? Minimum is at 4 minutes. The maximum is at 5 minutes. So we can find the middle between these two at 4.5 minutes. Now, remember, the absolute value is a distance from a number. So they are both 0.5 from this number. So to write that, I can write, remember, the absolute value is 0.5, so I'm going to take this absolute value, that distance, put that here, and then put the midpoint right there. So for your notes here, the halfway point is this. Whatever we're subtracting, very important, it's not adding, it's what we're subtracting from x, and then the distance from that halfway point is what it equals. The absolute value is the distance from that halfway point. You can write it down like this, distance from the halfway point. Alright, solving equations with two absolute values. To do this, we have to, again, set this negative. So we have 3x minus 4 is equal to x, or 3x minus 4 is equal to negative x. Now we solve each of those the same way. Subtract 3x from each side, which gives us negative 4 is equal to negative 2, or negative 4 is equal to negative 4. Then divide by the coefficient, so divide by negative 2 here, that cancels out. Negative divided by a negative is positive, so x equals 2. Or negative divided by negative is positive, x equals 1. We could plug that in and test it. 2 times 3 is 6, minus 4 is 2, is the same as the absolute value of 2. 1 times 3 is 3, minus 4 is negative 1. Absolute value of that is 1. Plug in 1 here. Absolute value is 1. That works. Okay, now notice that we have a number outside parentheses over here. So I'm going to set up two expressions again. 4x minus 10 is equal to 2, and then I've got to put this in parentheses, times 3x plus 1, or 4x minus 10 is equal to 2 times negative 3x plus 1. This one's a little bit tricky to set up right here, because the negative will only apply to that absolute value. Okay, so I have to multiply everything inside those parentheses. This is just the traditional way that we would solve. Boom. Distributive property, subtract, subtract, divide, and x is negative 6. Over here, this negative, we will do like distributive property. It's basically negative 1 times the parentheses, so negative 1 times 3 is negative 3x. Negative 1 times 1 is negative 1. Now we still have the brackets around the outside, so that's going to be a multiplication by 2 there. Everything else carries down as it was. 4x minus 10. All right, now I do distributive property again. So now I get negative 6x minus 2. This carries down on this side. I'll show you a little trick. We can do this in one step. I'm going to eliminate the smaller variable term, plus 6x. Okay, that eliminates it here. I've got to add it on the left side also. In the same step, if I'm eliminating the variable term on this side, I'm going to eliminate the constant on the other side. So those of you who've practiced this quite a bit, feel comfortable doing that, you can do both of those steps in one. Then we have 4 plus 6 is 10x. Over here, negative 2 plus 10 is 8. Divide by 10 on both sides. And x in this case is 0.8. All right. Now, you might run into something where you have what's called an extraneous solution. So that does not satisfy the original equation. So you can solve a problem like this. Okay, 2x plus 12 is equal to 4x. And remember, we have to do the other one. 2x plus 12 is equal to negative 4x. Now, if I solve that, it looks something like this. Eliminate the variable term, and then here I divide by 2. That cancels out the 2. X equals 6. On this side, divide by negative 6. So I'm going to get positive. Negative divided by negative. Over here, 12 divided by negative 6 is negative 2. All right, well, let's test these. If I plug in 6 up here, 6 times 2 is 12, plus 12 is 24. Absolute value of 24 is 24. 6 times 4 is 24. 24 equals 24. Good. Works. Plug this in. Negative 2 times 2 is negative 4, plus 12 gives me 8. Negative 2 times 4 is negative 8. An absolute value can't ever be negative anyways. So this one does not work. It solves the same way. I get that solution, but it's an extraneous solution. That means this solution doesn't work. You always have to check your solutions. All right, solving an equation with two absolute values. One last example for you here. Set up your two equations, one with a positive version, one with a negative version. Negative version, remember, distributive property, so we've got x plus 5 is equal to negative x minus 11. And then I can add the smaller variable term plus x, that is not x squared, that is just 2x, because remember, when a variable doesn't have a coefficient, there's a 1 in front of it. And then, since I brought the variable over here and canceled it out here, I'm going to cancel out this constant. So subtract 5, this cancels out, is equal to negative 16. Divide by 2, and x is equal to negative 8. All right, over here, I want to eliminate a variable term. And then that cancels out, this cancels out. 5 is equal to 11. It is not equal to 11. That's not a solution, obviously. So the only solution is x is equal to negative 8. All right, ladies and gentlemen, what was to be shown has been shown. That was 6 absolute value equations.